As I expected.
Hello. Hey, Charlie.
Hey.
Welcome to the YouTube stream for the moment, and happy to have everyone here who is here live and just in a second on the podcast. Exciting to be back together.
Yeah, thanks so much for having me back on the show. I really appreciate it.
Yes, it's really great to have you back on the show. You and your team are doing awesome work these days and making a big dent in Python.
Thank you. Hopefully a good dent, I guess.
Yeah, I guess you could make a good dent or a bad dent, but no, I meant that in a good way. Definitely in a good way.
I appreciate it.
Yeah, I think excellent work. It's kind of surprising how some of these tools just come in and just catch fire in a way. I don't know how you felt about it, but it seemed more than I would have expected. I mean, I did not expect your things to be popular, but they became really popular really quickly.
Yeah. I mean, it was different. With Rough and with UV, this sort of context around it has been pretty different, because with Rough, like when I started working on Rough, no one knew who I was or had any reason to care about what I was doing. The project just grew over time. And then I knew that when we were working on UV, like there would just be a lot more of an expectation around like anything we build.
Yeah, the spotlight was already shining, right?
A little bit, yeah. And that's awesome, because it means our stuff gets traction. Also, it comes with a lot of responsibility. It means anything we release, we're kind of committed to maintaining. So like, it's been very interesting. Like this kind of release cadence versus what happened with Rough.
Well, you have more people behind the scenes helping you out, right?
I do. Yeah. Thankfully. That's another
tell us, maybe that's a good place to just kick off our conversation is, we're going to talk a bit about Rough for everyone, and Rough was the thing that really launched all of this, but you started a company, Astral.
Yep.
Got some funding behind it.
Yep.
Building awesome tools. Yeah. Just give people the broad view of your world these days.
Yeah, totally. So, this all started when I released Rough, probably like a year and a half ago, maybe at this point. And at that point, it was really not just a side project for me, but very much an exploratory project. Like I was kind of curious about building faster Python tooling, really, and curious about getting better at Rust and all this stuff. And Rough, when I released it, it was a linter, or it is a linter, but it kind of brings a lot of different tools together. So if you're familiar with like Flake8 or Pylint, but also Black, Rough is designed to kind of bundle all those tools together. So it can detect problems with your code, it can fix them automatically, it can reformat your code. So often when we see people like adopting Rough, they're replacing like 20 or 30 tools with Rough. And there's a bunch of nice things about it, but ultimately it's very, very fast, and hopefully a lot simpler for users. But go ahead.
I was gonna say, it's really nice that it's just one tool that brings that all together. It's not a patchwork. Well, here's how we use iSort, and here's how we use Flake8, and here's how we use this, and here's how we use that.
Right. I think iSort's a really good example, because instead of having and iSort's a great tool, but instead of having a separate tool to do your import sorting, Rough frames import sorting as just a lint rule. And so you don't have to learn a bunch of different tools and figure out how to sort of merge them together. Rough, again, when I released it, it was just a side project, and it sort of took off. There were it was originally, I released it in part because I had this thesis that like Python tooling could be much faster, and Rough was meant to evidence that. It was meant to be an example of what I saw as like this potential to build really different Python tooling, and took off. A couple big projects like Fast API and such were kind of early adopters, and it just grew and grew and grew from there. And I started a company, Astral, shortly after, based on a lot of these ideas. So again, Rough in this context was meant to be, the goal wasn't necessarily to start a company just based around Rough, the goal was to start a company based around, the ideas behind Rough, which is, can we build really different Python tooling by well, it's all written in Rust. It's sort of an implementation detail, right? But ultimately, what we're trying to do is build like really high performance Python tooling, but also tooling that works together really well and simplifies things. So it's not just about performance; it's also about tackling a lot of, I guess, what I see as the complexity in Python tooling today, and really trying to, I guess, challenge certain status quos and respect others, but challenge some status quos in what it feels like to work with and use Python. And so, our focus as a company, right now we're very, very focused on our open source roadmap and our open source tooling. So that's Rough and now UV, which we'll talk about in a bit. And these are MIT licensed, fully open source tools that we build. And ultimately, our goal is to build and sell paid services that integrate really well with the tooling and are kind of like the natural next thing you need when you're building with Python. So, we'll never charge money for like the tools themselves; those remain free, permissively licensed. But our goal is to kind of build. Imagine you're building with Python. You need to deploy a web server. There's a lot of things that you need naturally to do that. So for people who are already using our tools, what are the natural next things they need, and how can we build really good services on top of the tooling that just integrate with it really well? So that's kind of the premise of the company. There's like really two focuses to the roadmap. It's like the open source and the commercial. And our goal is to have an incentive structure where we're just continuously aligned to like invest a ton in the open source and grow it as much as possible in a really natural way.
So you're not going to do like per line fix pricing. You get a million line fixes a month free, and then no, just kidding. I think it's an awesome model, and open source 10 years ago, it really looked, it was already super vibrant and super making huge dents in the space, right? Really a lot of people adopting it, but I think there was kind of a funding side that was a little bit missing. I still remember like, buy me a coffee type of links, like send me $10 if you like this. And that's not a job. That's hardly a hobby type of thing to get stuff done. You can't have a team of people focused on it. And it had traditionally really been around kind of a beneficial, I need to find a big tech company that's willing to give me sufficient amount of time to work on this project to sort of fund its existence. Or maybe I'm a consultant and I create Flask, but I consult on Flask, that type of thing. Right. And I think it's just super positive to see more direct ways people are making open source successful. I think,
I appreciate that. And I wish,
I think,
I sort of wish that there were more good examples of that working. There are some for sure. For me, it was pretty clear. Like it was immediately clear to me I needed to be working on Rough full time if I wanted the project to succeed. That's kind of a microcosm of the bigger challenge, which is like we wanted to build, like we really wanted to like professionalize the building of this, the work on this project, and bring in more people to help build it. And so, ultimately it's not charity, it is venture funding. And ultimately we need to build a business, around the tooling, to make it sustainable. But again, for me, I want the incentive structure to be such that like the open source is obviously free, open source, extremely permissively licensed, and truly open source. Like we have tons and tons of contributors. We have a huge community around it. I'm just glad that we've been able to bring in more people to kind of supercharge the development of it all. So I guess you touched on this before, but we're now 8 people. So we've grown. It was I guess a year ago it was just me. In March. So over the past our first 2 team members joined actually in March of last year, so almost exactly a year. And we're completely distributed. So we're We have people in US Pacific time all the way to Bangalore. So we're just, around the, like, open source, right? Like, we're kind of all over the world, and just building all this stuff out in the open.
It's such a good fit to be a distributed company as an open source with open source roots, because the tools of open source, in some degree for software in general, but especially for open source, is asynchronous,
Yeah.
semi connected, kind of the Zen of Get, but for the way you work, right? And it makes it super easy to hire just the most engaged people, regardless
Yeah,
of where they are,
exactly.
rather
Yeah.
than the people who are willing to commute to my office in the office park.
Yeah, it was, I would be pretty I'd be pretty surprised if a single person I've hired would have been willing to move to New York, which is where I'm based. From that perspective, it was a no-brainer, which is, and actually, multiple people we've hired, our relationship with them started on the repo,
Yeah.
in Rough itself. And then almost everyone we've hired, we, discovered through open source in some way, or had some relationship through open source in some way.
Yeah.
So yeah, it's also very much in the DNA of the company, which is, we actually also intentionally try to hire people who have been maintainers, right, and have a lot of experience with that too. We view that as a really important skill.
Yeah, that's excellent. So we talked about Rough. One thing I do want to give a bit of a shout out to is, I don't remember. I think I found this on Mastodon. I can't remember where somebody talked about it, but one of the things that Rough does, one, it changes code, which is awesome. I love your Rough format story, but it also just tells you, hey, this could be better. You're violating PEP 8. You're violating this other convention, or even a security thing, right? But the why of that, I think, requires a little bit of experience. Like, why should I use this kind of loop or that kind of
Right.
comprehension over another, right? It's people told me that who are much better, have been doing this longer, I shouldn't do it. Why?
Yeah.
And when you have 700 rules, there's a lot of why. And so you guys came up with this thing at docs.astral.sh/rough/rules, put it in links, that literally for each one of these has like a little example, and what is good and what is bad and when you should use it, and so on. You want to just tell people about this a bit? I think it's a massive.
Yeah, totally. So we obviously didn't have this when we started the project. And then we accumulated a lot of rules. Like, when we decided to add this, I think we already had like hundreds of rules. And the motivation for the format really comes from Clippy, which is the linter used in Rust.
Okay.
And Rust in general has a really good documentation culture. And Clippy has this nice format, very similar to ours. We've made some adjustments, but it's pretty similar around how you document lint rules, like what's the motivation and giving examples. So we were like, all right, we want to do this. And we just, over a very long period of time, and a lot of contributors contributed on this documentation, but it took like 6 months or something probably to document them all. And now we require it for all rules, so it's much easier to add going forward. But it was a huge effort to add this, and some of the explanations too are very extensive and detailed with lots of references.
Yeah. I pulled the one up for isort, unsorted imports, which is error I001. And it also talks about whether it can automatically fix it. What this does, why is it bad? So it says things like consistency is good. Use a common convention for imports to make your code more readable and idiomatic or Pythonic. And it just gives an example of bad, good.
Right. And
I think that's nice.
Yeah. And, we've started to put more stuff in here over time too. Like in some cases we let users apply automatic fixes that aren't completely safe, like by opting in. Like, it might change the meaning of your code, and you kind of need to be careful. And so over time, we've started to document that here too, like rules that have unsafe fixes. Why? Like, in what case might it break your code, and what should you look out for? So we want it to be a tool with really good, like we're kind of inspired by Rust in this way, because Rust has a really good documentation culture, and also the Rust like compiler itself has really good error messages. It's sort of famous for that. Like when your code doesn't work, it's really good at telling you why. I mean, it doesn't always get it right, but it has famously good error messages, and that's something that we try and channel to like when we make changes to configuration, like just putting extra effort into trying to make like those like error messages and those hints helpful. But yeah, it's a lot of work. So I appreciate that you called it out.
I'm sure it looks like a lot of work, but it's one of those things that's, it's where else are you going to get this knowledge, right? I mean, I know you can go search for one at a time, but in this aggregate, this is really good.
Right.
So Rough will fix a lot of these things for you. And one of the things that I like to do is I just have it integrated into my editor these days. So both with PyCharm and with VS Code, if I just say format this document, that's a Rough format.
Nice. Yeah. So we have we have a VS Code extension, and it supports formatting, auto fixing, all that kind of stuff. And
the PyCharm one's the JetBrains one's a third-party one, right? Someone else decided to make that.
Yeah, the JetBrains one is by Kudai, and that's like a community extension. We're considering doing our own at some point, because there's a lot of demand for. Obviously, we have a lot of users who use the JetBrains stuff. I mean, I use it, so we may do our own at some point. But there's a community maintained one right now, and that's based on. We have a sort of like a language server. So there's kind of like an underlying piece of technology that wraps Rough that powers all of these editor integrations. So like you can also use that from like NeoVim or like Sublime Text or Emacs. Like all of those editors support the LSP. And so you can actually, it's the same thing that powers the VS Code extension, just that's wrapped in some VS Code specific stuff, but like it's the same piece of technology. We're actually rewriting that right now to make it sort of like more natively integrated into Rough, which will let us do some cool things. So it should get like actually significantly better, I think, over the course of this year, because it's becoming more and more of a priority for us.
Yeah, cool. The whole LSP thing is pretty interesting. I think it's really opened up a lot of editors being better.
Yeah, it has, and it made it, like from our perspective, it made it way easier to build like editor integrations, because we just built an LSP and then it like works for like everyone almost. Like the JetBrains stuff, it does support the LSP, but I think only in the paid version, not in the community version. So like there's some limitations around it. But in general, like if you support the LSP, like it's actually very easy to build editor integrations that work with everyone, which is like super, super useful.
Yeah, instead of rebuilding your own integration for every single thing, which is not fun.
Yeah, it's a lot.
All right. Well, let's talk about the main project here. The main reason for being here today is UV. Tell people what UV is. This is your next big project, next big tool.
Yes. Yeah. UV, we released UV little under a month ago. And this is something that I've wanted to do like basically since we started the company. I thought there was an opportunity to build some really interesting tooling in Python packaging. And UV is kind of the first milestone in that. So UV, in its current form, it's designed as a sort of drop-in alternative to pip tools, like if you use pip compile, pip sync, and virtualenv. So it takes those three tools and tries to bundle them into one. And so it can do things like, given a set of input requirements, generate a requirements.txt file similar to what you get from pip compile. It can, you can do UV pip install -r requirements.txt, UV pip install black. So it's really intended right now to be a sort of, it won't always, we don't support absolutely 100% of what pip does, but it's We try to be pretty close. And so in many cases, the intention is that people can basically drop in UV in their project that uses pip today and get, in many cases, like very, very significant performance improvements. So similar to Rough, like some of the goals we had for this project were, one, it should be very, very fast. In UV, it's really fast. In particular, there's like a benchmarks.md in here, actually, if you want to click on that. Now scroll up.
Does that do it?
Oh yeah, that works too, I guess. That was smart of me. Yeah, so so it's really, really fast. Especially if you've already have if you have things cached, which is pretty common. So like often on your machine, when you're doing like pip install -r, whatever, a lot of those packages, you've probably installed them at least like once before on your machine. Or maybe you deleted your virtual environment and you're recreating it with the exact same dependencies or something like that. UV is like very, very well optimized for that case. So if you have a package that you're installing multiple times, like the installation is effectively free. And it's also a lot more like disk space efficient. We use kind of like, we store all of them in one place and kind of copy them into your virtual environment so that you don't have like many, many different copies of the package too. So this was all kind of taking techniques and inspiration from like other ecosystems and other package managers and kind of molding them to fit Python's model for how packaging and dependencies work and all the specifications. And so again, the end result is like you know, installing into a virtual environment a package that you've already installed before is basically free. Yeah, a lot of these things are just like way, way, way faster. Similar to Rough, like
dramatically faster. Yeah.
Yeah, and similar to Rough,
dramatically. And I think it's worth pointing out that like on one hand, we all have an extra 10 seconds, right? Or
of course,
whatever. But in the aggregate, all of these things are just like little paper cuts over your day, And so, yeah, sure, I can format the code and I could use something nice. And sure, if it takes 20 seconds, okay. But then you stop running it because it's kind of a hassle and you're in your flow. and this is kind of the same way. It's like, oh, I want to maybe see if there's some new packages for this project as I'm sitting down to work on it. Like, okay, well, wait for a pip compile to run, and you wait, and then like, okay, now it's done onto the development version, and you wait, and like, it's just some of these things that are instant. You just ask the question more, and it just doesn't break your train of thought,
Totally. I think there's like maybe like 3 different things that come to mind here when we think about performance. Cause like, yeah, okay, in this case, like it may not seem to change your life if you're going from 1 second to 50 milliseconds. But I think 3 things come to mind. So one, like for companies and large projects, this can actually be like a really big difference. And so if you're at a company and you have like a big monorepo with like a bunch of different sub projects that all have requirements files and you want to bump a dependency, that can be like that at that point you're talking like 15 plus minutes for a command. And so like the larger the project gets, obviously the more performance matters, and the more it helps out. And we're trying to build tooling that can basically scale, I don't know about like to arbitrarily large projects, but like to large projects and useful for companies too. The other thing I'd say is I think there's something that happens like when you make something like way faster, it just changes a lot of the ergonomics around what it's like to do things. And so, in this case, like, okay, so installing into a virtual environment, a package that you've already installed before is free now. And so how does that change things? It's nearly instant. So how does that change things, right? So that means like, if you mess up your virtual environment and have to delete it and recreate it, it doesn't cost you anything. It's totally ephemeral. You can throw it away and recreate it at any time. And like, that's just like a different, like, it sounds small, but that's kind of like a different relationship to virtual environments than before, where it's like, okay, I created the virtual environment now. Oh no, my virtual environment's so messed up. I got to recreate it. Like, we want to just change a lot of the dynamics around some of those like abstractions. And then the other thing is this performance budget, or this, if you think of performance like a budget, this buys us a lot of room. And so like the fact that we are so fast on some of these things means that we can do things that otherwise might be like prohibitively slow. And this is more sort of forward looking and for the future. Like one thing that we're thinking about a lot right now is this idea of like resolving Python dependencies for many platforms, because it's a little bit complicated, but you know, pip compile and pip and UV, they're really designed to only work on like the current Python platform and the current Python that you're using. So if you're on like Mac OS and you run pip compile or UV pip compile, it will give you dependencies that are correct for like Mac OS and your current Python version, but they might be wrong on Windows, because in Python you can have dependencies that vary based on things like the current Python version or the current operating system. And so
one example would be UV loop.
Yeah.
Right. For people who are trying to speed up.
I think it doesn't work on Windows.
It doesn't work at all on Windows. That's right. And so
yeah, so that's a very common one.
Yeah.
And it's actually very common that this is a very common thing. Like on like lots of really, really popular packages have these kinds of these what are called markers, which basically makes the dependencies conditional based on the current Python. And so, you know, like in pip and pip tools, UV right now just locks for the current Python. Poetry and I think PDM, but Poetry for sure does this very interesting thing where they actually try to resolve for like all possible platforms. And that's something, it's really convenient because it means that like you kind of do one lock and then any user anywhere can like use that and it works. And it's kind of like guaranteed to be right, as opposed to maybe it doesn't work on Windows or whatever else. And so we're pretty interested in like that, adding that behavior, and that's going to be like more expensive. And so if we have something that's really fast right now, it kind of like opens up a design space of interesting things we can do to solve that problem while still being, you know, very fast. So that's kind of how I think about performance. Like, I think people like a little bit underrate how much of an impact it can have on even small interactions. Because once you try something that's much faster, it's often hard to go back to the other thing. But I'm glad you've had that experience at least.
Yeah, absolutely. A couple of interesting comments. Danny says, if it takes 10 seconds, I go to triage that issue on GitHub and come back 5 minutes later, right? Like, that's kind of where I was getting at with the flow stuff. It's like, okay, I'm ready to mind wanders and you're kind of like starting over, right? Yeah. And then Henry out in the audience also says, hey, Henry, it says it also, this doing things so quickly, it encourages good environment usage, because if doing things the right way is just as easy and as fast as doing it the wrong way, you might as well do it the right way.
Nice thought. That's a nice thought.
Yeah. It is.
Yeah, I mean, I think there's there are certain things though where like we aren't any faster, and I'm interested in the thinking about like those and what we can do about them. Like a common one, or the most obvious one, is in Python, sometimes when you install a dependency, you might have to build it from source. And you know, in Python, you often are installing things like NumPy, which includes some native code. And so actually turning that into something that your system can run is kind of expensive. And you typically don't have to think about this with NumPy, because they ship what are called wheels, which are kind of like these pre-compiled artifacts. But not all packages ship wheels. You could be on a platform that doesn't have a wheel for a variety of reasons. You might get the raw NumPy source code and then have to you get the raw NumPy source code and then have to compile it down into a build distribution. And like for us, if we get into that situation, it's like not going to be any faster, because like we still have to build the thing from source, like just like
that's the
like
slowest part of the whole process.
Yeah. And so there's like some, you know, there are some cases and some bottlenecks where like I'm kind of thinking about how could we do even better there. And there are actually things that are changing in the standards that have made this a little easier. Like there's this new thing called metadata 2.2 sounds cool, I know, but it basically lets you like read the
You thought you liked
metadata.
metadata 2.1.
Yeah, if you,
Just you wait.
yeah, we're actually on 2.3 now.
Okay.
But
I just kidding.
but uh, the point of that is like it's a standard that makes it so you don't have to build the thing as often. Like if you just want to know the metadata of NumPy, for example, you may no longer need to build it, and before you did. And so the standards are moving in a helpful direction here, but I just thought I'd call it out because like the source distribution, there are cases where it won't be faster, and I'm pretty interested in those, but people should know that they also exist.
Mm-hmm. There's also, it's not just time, there's also security issues around that, right? If things are still based on building source from source and then running the setup pi to see what the metadata is, it's both slow and also potentially running arbitrary code just to pip install a thing, which can make you, I mean, I don't know. Rarely has anything gone wrong with just installing and running arbitrary code off the internet, but sometimes it could go wrong.
Yeah, it would be nice to get to a world where that's not required for at least for dependency resolution, and like the standards are moving in that direction.
Yeah, exactly. I mean, you might, if you're going to use it, you're going to have to get it. But if you just want to know, well, what versions do I need to put these two things together? You shouldn't have to do
that. Exactly. Because today for NumPy, for example, if you didn't have a wheel, you would have to run some arbitrary code to ask it for its dependencies.
Yeah, exactly. Well, let's talk about some of the usages here. I see some more interesting comments in the chat. Well, I'll get back to them. First of all, you know, is it like Highlander the movie? Should there just be one? Is UV a thing that I put into, say, my requirements file if I want to use it, or do I install it just once for my machine? Like, what's the scale of UV?
So there's a lot of different ways there's a lot of different ways to install it. You definitely can install it into a virtual environment. My general recommendation would be to install it on your machine once, because an interesting thing about UV is you don't need Python to install it, and it doesn't have, you need to have Python on your machine because we need to be able to, for example, build source distributions or know where to install the thing, right? We have to install into a virtual environment somewhere. And so you have to have Python installed on your machine, but UV does not depend on Python. So like it can install into arbitrary virtual environments or into arbitrary other Python interpreters. So that's why we generally recommend using like these standalone installers that we have at the top of this snippet on the screen. So like the curl and the PowerShell invocations, those will install a single binary on your machine that's UV. And from there, you can use UV to install into virtual environments that it creates, to install into your system Python, to do whatever. So like I would say most people, based on the statistics, based on our download statistics, most people still install UV with pip, which makes sense, which is not that surprising to me. But I would generally recommend having like one UV install on your machine. Although if you do install into a virtual environment, like that's also totally fine. Like nothing's going to go wrong. It's just not completely necessary because a single UV can already install into that virtual environment.
Right. You're never going to import UV.
No,
I mean, you might, but in general, people are not going to.
I think you can. I'm trying to think what would happen.
It's not like so like things like PyTest and other things. A lot of times there could be just one of those, but then you want to use fixtures and you need to import something out. So then it really needs to be in the virtual environment and accessible like a library. But this is just something you run maybe even before your virtual environment exists, right? Like it really kind of does ideally exist outside it, I think.
Yeah, ideally it exists outside of it. And there are some cases where you'd want to install it within the virtual environment, but ideally it exists outside of it. The other thing that's nice about using the standalone installers, like at the top here, is soon we're going to ship like a self-update command. So you can do like UV self-update, and it will update UV to the latest version. And we can't really support that if you install it with a different package manager like pip or brew. Those have their own upgrade commands, obviously, but like if you install it with our installer, then like we can control the upgrades and stuff like that, and provide some other features. So that's
Cool.
generally what we recommend, but obviously we're always going to support like installing with pip and stuff too.
Yeah, I'm all about PipX these days. I really like
Yeah, or
the
PipX,
way
that's mine.
PipX. Yeah, PipX really. You can just say kind of like Brew. You can say upgrade all my Python CLI tools. PipX upgrade all, and basically,
Yeah.
I find Rough and UV is just you guys are moving super fast, and there's frequently an update.
There are often updates. Yeah.
Yeah.
Yeah, and then the UV interface, like it's meant to be pretty familiar or it's meant to be, I guess, hopefully very familiar to people who have used, who are already using pip and other tools. And so like UV VM creates a virtual environment, and then we have this sort of pip subcommand. So like UV pip install Flask, and that doesn't call or use pip in any way. We're just using pip here to convey what the interface looks like. And part of the motivation there is at some point in the future, we probably want to add a new interface to UV that's a little bit more high level. So you could think of something like Poetry, where they have like Poetry install. They have this sort of higher level interface for interfacing with packages. We want to do something like that. And so that's why we left the top level of the interface clear, because we might kind of like innovate and like ship a bunch of stuff that would otherwise break this interface. So like by putting this stuff under pip, we basically created this like isolated space where we can make sure that those commands like keep working no matter what we choose to change in the future. And it's very similar to pip's interface, right? It's like pip install, then it could be a package name, it could be a -r requirements file. We support editable installs. We support like URL dependencies, Git dependencies, all that kind of stuff.
Right. All the stuff you might normally do pip install something, for the most part, that's the same.
Yep. Yeah, exactly. And we support a lot of the same flags too that like pip supports. So like -- index URL, -- extra index URL, like -- no binary, like all that stuff. Like we've put a lot of, we don't support every flag, but we've put a lot of effort into supporting a lot of them, and we've added more over time. Like now we support like -- no build isolation and stuff like that maybe most listeners have never even had to look at, but like these things matter in some circumstances. And so like over time our goal is to add like more of the interface, but I would say for common use cases, I would expect that it just works. Like just adding UV up front, like it should just work. Now, as you become more complex, it won't, and you'll run into some. We have a whole document of like subtle ways that we deviate. Some are intentional, some I consider bugs, right? Like some we want to fix over time. But the intention is that for most people, we want it to just work. Once we fix the first round of bugs following the release, of course.
Yeah, sure. So you've got a UV VENV vimp for creating a virtual environment. And it has a lot of the flags that Python -mvenv would have, where you can say, bring along pip or upgrade things or set the prompt name, that kind of stuff, right?
Yep. Yeah, exactly. Yep.
Similar for UV pip and then stuff. What I find I do for most of my work, at least if I'm not trying to teach or do a presentation where people are like, what did you just do? Is I'll have kind of aliases, right? Like UV pip install -r requirements.txt is just PIR, pip install requirements, things like that, right?
Yeah.
And so try to just take the common stuff, and it doesn't matter if it's pip or UV really backing it from my CLI ergonomics, right? I use my alias, and if I want to change that, I just go and edit it. And so for me, it was super easy to switch to adopt these things, because I'm like, I edit my ZSH RC file once, and now everything I just do the same stuff, and it works, but the new way faster.
Yeah, and the goal of like pip compatibility has been interesting, because there are actually like some things that we very intentionally want to do differently. And like, I won't speak for the pip maintainers, like, but I think in some cases there are probably things that they would do differently too if they could.
I think so too. Yeah.
Yeah, because like Pip, I mean, Pip is extremely important, and its number one goal is like, it needs to be like robust, right? It needs to keep working, and it needs to be compatible, and because it's truly like the cornerstone of like a lot of the Python ecosystem, and so.
Yeah.
Pip, it's harder for them to change things, especially in a breaking way, and they have to be really thoughtful and do that over a long period of time. And so we're in kind of a privileged position, honestly, because we come in with a new tool, we can actually choose to do things differently. And some people will get upset about it, obviously, because they're like, this isn't exactly how Pip does it. I'm trying to hold firm on some of those things and also be open-minded on others, right? But like, like one thing that we do that's different, that's I guess maybe it's not evident from this screen exactly, or I guess it sort of is. So when you do UVVM, we default to the name .vm. So like if you don't provide a name, we just default to .vm. And there was a PEP to make that a standard that got pulled back, but like it's not like we're trying to make it a standard, but I just think it's a good default. Like we want to abstract away some of this stuff, and so you can just like have a virtual. You can obviously pass a name if you want, but we default to .vm. That's different from other tools. And then, the other thing is when you do UV pip install, by default we require a virtual environment, and so if you do UV pip install Flask and there's no virtual environment, like we'll error. And it doesn't have to be active.
Yeah.
We'll look for it in the current directory, even if it's not active. So like if you do UVVM, then UV pip install Flask, like it will work. And in my opinion, it will do the intuitive thing, which is it will install into the environment in the current directory. So it's like, it's trying to provide
traverse up. Like if I'm a little farther down, it'll go up and say, that's amazing.
Exactly. So it'll find the virtual environment in the current directory or any parent directory. Like for me, that's just like a nice default workflow that encourages virtual environments and like doesn't get in your way about it. And we do have a flag for installing outside virtual environments, but the difference is in UV, you have to opt in if you want to do something like install into the system Python. The virtual environment, it's very virtual environment first, while abstracting away a lot of the details of virtual environments. So there are things like that where we need doing it wrong, decisions. Right? Yeah, in my opinion, yeah. And I think, and it's nice because we can start with that behavior, and we're in a privileged position because we can start with different defaults.
Yeah, for sure. So if I do, excuse me, if I do a UV VNV for a virtual environment, then maybe I UV pip install something. But then I forget and I pip install something else. Does it break? Is it okay?
As in the third time there's no UV?
Well, yeah, exactly. Like, so I've been UV pip install something, UV pip install that. And I just, I forgot this thing. I just pip install. Oh, I forgot the UV.
No, it shouldn't break. Assuming, so let's say you activate the virtual environment.
Yeah, it's already activated.
Okay, cool. So you do UVVM, you activate the virtual environment, you do UV pip install Flask, and then you do pip install Black or whatever. That should work just fine, because like the thing that we ultimately create in the virtual environment, like that's all based on standards. So like the stuff that we do in the virtual environment to install packages, it should look like roughly indistinguishable from what pip would do, and it's totally interoperable with pip. So like similarly, if you did pip install and then like pip install Flask and then UV pip uninstall Flask, like that would work correctly. Like pip would install Flask and we would remove it, because everything that pip and UV are doing in the virtual environment is based on standards. So the way that we add and remove packages, all that kind of stuff, it should be totally interoperable with other tools.
Okay, cool. PyPI is pretty good at having analytics around what packages are being downloaded, what's popular, what platforms. Do you do anything like send a user agent or something so that people could answer the question, well, how many people are using straight pip and how many people are using UV in a year?
Yeah, we set a UV user agent, and right now it's just UV in the UV version. there's an open issue in the repo from Pradyan, who works on pip, that outlines all this stuff that pip includes in its own user agent, which we want to add, which is pretty interesting. I actually didn't know this. So pip in its user agent includes a lot of things about the current Python platform, data that they use in PyPI basically to inform decisions, like, oh, no one's using Python. This is just, I don't think this is actually how it's used, but just an example. Oh, no one's using Python 3.7 anymore. Let's like lower priority on that because no one's installing Python with Python 3.7. And so we want to add, we don't have that right now. We're planning to add it. But yeah, it will be interesting to see we can get statistics over time too on like UV and pip and how common they are in different dimensions.
Yeah. You know, one thing that would be kind of fun to have is, I'm not sure if it's at all interesting to you, but to have some kind of cron job or background thing, or even if you just interact with UV, if it kind of kicked off sort of a background process that did its thing. But, you know, take the history of maybe the top 500 packages plus the ones you've used, and just kind of keep a cache up to date on your system. So if you're on an airplane or you're in a coffee shop, or for some reason the internet's not great, like it's kind of pre-filled the cache and everything's there, and then kind of keep it in sync. That might be fun.
Yeah, we do have a dash offline flag, which will like it forbids network requests, obviously, but like it'll try and do the full install without accessing the network.
Yeah, that's cool.
It would be cool to pre-fill the cache.
Yeah, but it's just like, you know, if you're a UV user and you sit down on your computer and for some reason the internet's out, I'm at a conference, I'm doing a talk, and it's got the dreaded, terrible conference Wi-Fi. It's not the end of your demo. It's just like, yeah, see how fast this is? It's amazing. You know,
yeah.
Anyway.
Yeah. It was actually, it's actually funny because like the benchmarking, like when we do benchmarks, like benchmarks can just vary so dramatically based on like internet connectivity, right? Like that is often the bottleneck. Yeah. I mean, it's clearly not always the bottleneck because we're able to be faster than other tools. So like if it was always the bottleneck, I don't think that wouldn't really be true, but it matters a lot. And so sometimes I'll throw on macOS, they have a tool called Network Link Conditioner. So you can actually force
like drag your network limit down.
Yeah, you can force it down, and the categories are like, it's not literally called like bad mobile phone or something, but that's like basically what it is. Yeah, it's like very lossy edge network. Like those are like the pre-built category. It's pretty funny, but like it is actually, that's a very helpful thing for benchmarking. Yeah, and sometimes actually, if you have a really good network connection, sometimes it's actually helpful to set that anyway to a pretty good level, because then at least it'll be like very consistent across your executions. Anyway, something I've learned over time.
Yeah, that is super interesting. So one of the things I think is interesting to consider here is, obviously this is way faster. I saw some of the announcements and some of the discussion around the announcements, and the people were really surprised how fast this is. And I think I don't think Rust is the full answer. You mean, you tell me if I'm wrong, but like one part, obviously making the code run ultra fast, that is an important part of it. But it also seems like you all have rethought some of the internal algorithms and some of the caching and some of the ways things work, maybe with a fresh take on it, where you're not constrained by the way it's been done for many, many years. So what elements are at play to make it as fast as it is? Is it just Rust or is it something else?
So Rust is important, but like the way I typically frame it is that Rust is kind of like an enabler to writing really fast programs. Like it forces you / lets you care. It forces you to / lets you care about certain things that matter a lot for performance, that like in Python, there's actually just no way to care about them. Like I'm talking specifically here about like memory allocation. Like in Python, that all just kind of happens. In Rust, you're forced to think about, am I going to allocate memory here or not? And like, when is it going to be deallocated and all that kind of stuff? And so that unlocks the ability to care and like be really careful in how you manage it. so Rust is like Rust is an important part of the success story here, but I think it's like really, I think it would be really like very incorrect to say that it's like all about Rust, and it's not a Rust versus Python thing. Like,
right. Like if we could just recompile pip with
yeah. So if you took pip,
Python or something, boom, it would just be it wouldn't be as big of a deal, right?
If you took pip and just like rewrote it line by line as close as you could in Rust, like it would probably be faster than pip, but it would not be nearly as fast as UV. Like we just do a lot of things differently, and part of like, I guess evidence for this too is like throughout the development of UV, there were like multiple pull requests that sped up like UV as a whole by like 30 to 50%. So what does that say? That says that like there's lots of different, those were all Rust programs, right? So like we were able to write the same Rust program many times, optimizing it more and more and more.
Right.
And so there's like so much engineering that went into making it fast. Some of it's like how the cache is designed. That was like a really important piece. And that's actually something that like pip could also do. I think like it's possible a good outcome here actually is that like pip is able to take some of these changes and incorporate them over time. And we are kind of the guinea pig for that. Like we're going to kind of change user expectations a little bit about how the cache is set up. Like we're going to run into bugs about platform compatibility. Like we're going to run into bugs based on this cache design, right? And like hopefully that could at some point help inform pip if they choose to redesign their cache this way. The cache design is a really big thing. And then just a lot of like profiling the program, figuring out what the bottleneck is, and then like solving the bottleneck, and just like really intense engineering work that was not me, but was like other people on the team to optimize some of that. Like a good example is it's okay, it sounds silly, but like we found that a bottleneck when all the data is cached and you're trying to do a resolution, so there's no network requests, everything's local. One of the bottlenecks that we kept running into was parsing and comparing version specifiers. So like in Python, when you have a requirements file, you have like fast API is greater than version 1 or whatever. And then in the fast API file, you have like fast API version 1.0.0, blah, blah, blah. So like those, like parsing those, and then we were comparing those. We were doing comparisons between version markers like so many times because it was just a constant thing in dependency resolution. It's like, can I use this dependency? Well, does it fit into this range? So Andrew Gallant from our team like rewrote that parser and the version comparison specifier, and it's like one of the most incredible pull requests I've ever seen. Like it's like so interesting. Like every commit in is like so interesting, and he like optimized it so massively that it was like he's basically representing the version in the end by like a 64-bit or like a U64 integer, and comparisons is just like compare the two integers, and like there was just so much engineering that went into it, and it sped up the cache case by like 30%. And so there's just a lot of engineering that went into it, you know, again, it's harder for pip to do some of those things because the code bases they have actual users to support, right? Like we were able to do this before we launched publicly. Like we could break things, like we can do things, you know, we can make massive changes to the code base in short periods of time. So, you know, we're in kind of a privileged position to be able to really optimize the performance like that. But, you know, it's a big part culturally of what we wanted to do too, is like, we're going to make this thing extremely fast.
Yeah. I'm seeing also interesting secondary effects, you know, talks and Knox, I think that's talks, talking about using it, making it faster. Just now out here, Henry says build 1.1 is faster from looking at UV, and the next version will also add UV as an installer choice, which is pretty impressive.
Yeah, that's been a really cool, that's actually something I didn't really anticipate, but I'm really glad has happened, which is that there's a little bit of like, we ended up building something pretty modular. And so there's been a little bit of or a lot of like integrations with UV that people have been building. Like Bernat had the Tox UV thing that was out like within a week, I think, which was like use UV to power Tox in different ways. Knox, I think, supports it. Build, PyPA/build. Um, uh, you know, I've talked to the Hatch maintainer. You know,
Yeah.
he's pretty interested in making UV like an optional backend for Hatch. So like that's really cool to me because it's all just like magnifying the impact. And again, I don't know how much of that I anticipated, but it's really cool to see that like you could plug it into these other tools and they can just like go much faster. So
Yeah, it's
I don't know. For me,
incredibly cool.
that's actually been like a big highlight from the release. Honestly, has been the reception from like other maintainers of other tools who have been excited to integrate it in different ways. Because it's just not that just didn't happen. Like Rough wasn't nearly as much of a fit for that kind of thing. Like there just aren't as nearly. There are some, but it's just not as natural to have like integrations with Rough in that way. But
Yeah.
for UV, it makes a lot of sense, and it's been really cool to see.
Yeah, it's more UV is more of a building block than Rough is. Rough fits in
Yeah.
editors and CI and stuff. And yeah, okay.
Yeah, and
Couple-
there were other tools, but yeah, it was
Sure.
it's mostly an end user thing and not a library, I think.
All right. All right. So a couple interesting things out in the audience. Let's knock them out. Okay. So Tushar asks, and this is I think a big tension that's building in the Python packaging space is do packaging tools use Python to do stuff, or do the packaging tools control the Python? Who is controlling whom here? And so Tushar asked, will UV also install Python sometime soon? Can I just express, hey, I want to use 3.12 on this and these dependencies?
Yeah, we almost certainly want to do this. I don't think it won't be required. Like you can still use your own Python, but we almost certainly want to add Python bootstrapping. So like that's another reason why the dream workflow is like you use the standalone UV installer, because then it's like it will actually install Python for you too. And so like the reason, so then it's like you don't have to have Python on your machine basically to start being productive with UV. You can just bootstrap the environment for you. And we can also do, you know, yeah, it would just be nice if you did, you know, pip compile, like UV pip compile -- Python 3.13 or something, and then we just like bootstrapped Python 3.13 and did the resolution on your machine. Like that's kind of the workflow that we're trying to build towards.
Yeah, since you're so UV centric as well, it could be UV VNV, you know, dash version.
Yeah, 100%. Yeah,
or
and then we bootstrap it. Yeah.
If you don't have, if you've got it cached, you just give it, and if you don't, then you get it on the machine.
Exactly.
Yeah.
Yeah, so we'll definitely do this. Again, I do think it's important that it's not like required to use like the UV Pythons.
Yeah.
We actually kind of had to do like a minimal version of this for our CI and testing. But it was a bash script, and then I think it became a Python script. But eventually, it would be like built into UV. Yeah.
Yeah. Yeah. I think that would be really.
Yeah, I think it'll be super
really
cool.
Quite awesome. Yeah, I think it will be too. Let's see. Tushar also says loves that the -- require VNV.
Yep.
As a thing. He thinks it'll become the default, and also points out for those who don't UV that pip require virtual env as an environment flag is in your RC file is pretty nice. I need to do that just the other day.
Yeah, you can configure
I installed that into my into the wrong spot.
Yeah, so pip can be configured to require virtual envs. Yes.
Yeah, I do something weird. I'm actually looking at my terminal behind our shared screen meeting here, and my prompt says global venv. And so one of the things that I do is I have if I log it, if I open up my terminal, it already has an activated virtual environment that's just for whatever.
Oh, interesting. To just avoid messing up your system Python.
Just to avoid messing it up, or so I can I can just make that virtual environment the version of Python I want it to be, even if it's not the system one in general that I want to set. You know, just like it's its own thing. And so it wouldn't actually help me, but I still like that because
that's smart. Yeah, that's it. I mean, that's smart.
Thanks.
Yeah, I've learned a lot about like, oh my gosh. I mean, I've learned a lot about packaging. Like, I didn't know like anything about packaging, you know, like 6 months ago. I shouldn't admit that because it's really bad for my credibility, but like I've learned a lot about packaging, and in the past like 2 weeks I've also learned a lot about like system Pythons, like how Python is installed, and like how on like older versions of like Debian, like Python, they do like a lot of customization to Python that makes it like really different from like anyway,
Yeah,
I learned like way more about this than I ever thought I would.
I think it's
So
fine to say
I'm
that.
out on system Pythons, but we do support them.
Yeah, awesome. Someone asked me like, "No, Michael, you must know all of the standard library." I'm like, "What are you, crazy? No.
Yeah.
Why would
There's
I
a lot of
learn
stuff in
every
standard
single detail?"
library. Yeah.
Yes, exactly. And I think it's the same thing about packaging. There's like so many edge cases. If you never interact with an edge case and you don't care about that edge case, why would you take the week or whatever to study it? Like it's irrelevant to you until you need it.
I'm
And
trying
now
to
you've
remember.
dove in head first here. So then you're in the deep end with
We
it.
spent so much time. I shouldn't even bring this up, but we did when we were whatever. I won't tell the whole story because I need to not. But like we did consider like lots of different names for this tool, and multiple times we considered a name, and then it turned out to be a standard library module that none of us had ever used. Like at one point we wanted to use Wave, WAVE.
Okay,
but that's a standard
that's
library
fine.
module. Yeah. And I was like, oh, I had no idea.
Is that for working with Wave audio files? Probably it is.
Yeah, like WAV files. Yeah.
Yeah, interesting.
Yeah.
Yeah, there's a bunch of stuff. There's the whole dead batteries and removing certain things that like, I mean, I know it's technically in here,
like a great library, but some of these things I had never seen.
Yeah. Well, it's naming tools and packages is its own whole special deal. And we have 500,000 packages in PyPI. And so how are you gonna not conflict with that? Have an interesting name that's not primed for typo squatting.
Yeah, exactly.
Hard.
Yeah.
It's a hard problem.
Yeah. I don't even get me started on name stuff. Someone actually donated this name to us, which is very kind of them.
Oh, that's actually very cool. Very cool. All right. One other thing I do want to talk about here. Kanishk asks about, is there a future where Rye, RYE, and UV go hand in hand? Also great work. But maybe just talk a bit about Rye. That was by Armin Ronacher, and it kind of had a similar Zen as UV, but really different.
Yeah. So so we're taking over like maintainership of Rye. And we've just been like, I think I started talking to Armin like right after Rye got released, which was PyCon last year. I think it was during PyCon it got released. And we talked like shortly after, and we just found that like we were trying to solve a lot of the same problems, and we had like very similar vision for what we wanted packaging to be, but like we were coming at it from very different angles. Like Rye kind of came at it from, let's solve the Python bootstrapping problem. So we're going to ship a Rust
seems like its
tool.
main focus. Yeah,
exactly. And then internally, it was actually using like pip tools and pip to do installs and resolutions. And then the thing that Armin came to realize was like, if you want to fulfill this whole vision, you kind of need to like reinvent a lot of those internals. And meanwhile, like we were building UV, which was like basically those internals. And I was like, we're going to put a lot of effort into like building this packaging stack. And so we kind of found that like it was just we were trying to get to the same place, and we were putting in a lot of the engineering investment on building a lot of kind of building blocks. And we want UV to evolve into something that could like fully replace Rye. So we want it to evolve in that direction. And in the meantime, like we're going to keep maintaining Rye and kind of using it as like a little bit of a test bed for like experimental things. Like Armin added like PyTest support to it, for example. So we're kind of playing with like, that's meant to be more of an experimental test bed for like the future that we want to achieve. And over time, we're going to kind of evolve UV up to the point that hopefully it can fully replace it, and then we can provide a clear migration path for it. So we're going to keep maintaining it. It is our intention for UV to like supplant it at some point in the future. But it'll take us like time to get there and be able to do all the things. But the visions were just so similar that it seemed like it made a lot of sense to try and consolidate and kind of team up on it.
Yeah, they do seem pretty similar, and I can see the direction that you're going, and it's going to make them more similar.
Yeah, and it'll take time. And like, this release of UV is like, it really is like the first release, it's like like I kind of view some of this stuff as like pretty low level. um like we want to build something that feels higher level and more automatic in the future. But these are kind of like the ability to install and uninstall and resolve packages. These were like the fundamental things we needed, and need for anything we were going to do.
Yeah.
And so this goal was really, let's take those and let's put them in a form that's like immediately useful to people.
Yeah, for sure. One more Rye question. Then I have other questions. So UV will replace Rye. Do you recommend using Rye or UV, or what's that side of the story right now?
Yeah. It kind of depends on what you're doing. So like Rye uses UV under the hood. So like Rye uses UV for resolution and installation. So if you're using Rye, you're using UV. I consider UV to be like, especially if you're like a company or something, like I would say UV is production ready for you. Rye, you're buying into a little bit more of something that's a little bit more experimental. Like I think Rye is a good fit for like personal projects, hobby projects, libraries, smaller projects. I don't know that I would like, you're just buying into more change, I think.
Yeah.
And
It's
so
not going to be
if
the
you're already
foundation of your mono repo that's got a million lines of code and 100 people on it.
yeah, you can certainly try it, but you should know that you're buying into something experimental is the way I'd put it. Whereas UV, like you could also view UV as experimental if you want. Like it's very new, right? Like we're like when we launched, we had, I mean, I think having issues is actually good because it means people are using your project, but we had like hundreds of issues. And we've closed like hundreds and hundreds of issues since we launched.
Yeah, you guys have been
like,
super. Yeah, you've been super responsive on it. Like you and I have had some exchanges there.
Yeah, we did.
And yeah, that's some nice changes I saw going on. But like I said, like almost every
it's just
day
getting
there's
like
a new
way
version.
better.
It's great.
Yeah. And it's just getting way, way better. Like that's the thing about developing in private is like we just, once we released it, we actually had users who could use it and tell us all the things we missed, tell us all the things we didn't think about. It's just like every week getting way better. So like it's getting more and more stable. And like I would use it in production for my stuff for sure. And I recommend it for production. But like Rye is just a little bit of a different story. I think with Rye, it's not like we're going to shut it down tomorrow or anything like that. Like it's going to continue to be supported for sure. But you are, and I think it's branded this way, which is you are kind of buying into a little bit of an experimental tool.
Yeah. Also a bit of a workflow, like the way
it's a very opinionated workflow. Yeah. Whereas UV is more designed to kind of slot into existing workflows.
Sure. It's a little more foundational. Speaking of which, I really like that, so many of these tools have their complete own way. Like I know you're going to do that, but we're going to start up our shell and then you're going to run these 3 commands and then we're going to have our own lock file and we have our own things. And it's amazing if you drink the Kool-Aid, if you go all in on the tool, but if you don't, then it's like, okay, well, what is this thing even doing? It's more in my way than it's helping me, and so on. So the fact that a lot of this is kind of baking in the pip tools way of there's going to be this external tool that can manage some of your stuff for you, but it's not prescribing a workflow. 100% props for that. Love it.
Thanks. Yeah, I wanted to build something that, again, I use the word like modular a lot, and I think it can mean different things, but like Rough was kind of like this too. Like in Rough, you can use it as like just a linter or like just a formatter or both. And like with UV, like you could use UV like just to create virtual environments or just to do dependency resolution, but use pip for your installer or something. Like it's designed to be kind of flexible in how you choose to use it. And I want to maintain that. I think we'll start to introduce more opinionated workflows, but I think that we'll continue to provide this kind of pick and choose model as well.
Yeah, I think it's great. It lines right up with the way I do things. And also I really like it as both someone who might do presentations either at a conference or in a course or teaching, because you're not putting, the whole virtual environment stuff is already such a kind of a large barrier that comes a little early in people's learning path, right? They're like, I want to run Python. I want to run this thing. Whoa, you don't just install this. You don't just use it. We're going to talk about virtual environments. Like, I don't care about those. I just want to run it. Like, yeah, but you're going to need to install something. So here we go. Right. Adding more workflow and more specific ways of working there, I think, while trying to help, a lot of times they end up just adding more friction at the start.
Yeah. Yeah. And like, I guess my philosophy there is like, I want us to like embrace virtual environments. Actually, Rye has this philosophy too, which is like Rye does use virtual environments, and like virtual environments actually have there's a lot of benefits to embracing them. Like all the editors and such, they're all built around they all are all built around virtual environment detection and stuff like that. But I want it to feel a little, honestly, like it has a really bad reputation, but I want it to feel more like node modules, where it's like
I agree.
something, it just kind of works it just kind of sits in your project, and your project just does the right thing. And I know people make fun of node modules usually for being big, but that's the developer experience I want, which is you don't think of the virtual environment as this weird other thing. It's just kind of like the project environment, and it just kind of works. And I think you get that by not like shielding people from it, but abstracting some of it away for people that don't need to think about it.
Yeah, there was an amazing, it's not a joke, but it's, I guess, something that's a prank that somebody came up with. Here, I'll put it on the screen. It's called When Everything Becomes Too Much, the NPM package chaos of 2024. And I was just, as you were talking about node modules, this is more of a,
I haven't seen this.
It's amazing. So it's more of a statement of like, well, how super interdependent, or how many combinatorial or transitive dependencies does a couple of NPM things have? Like, for example, I used Tailwind, but there was maybe 50 things in my node module for just using Tailwind in my project, right? So anyway, this one is an NPM user named Patrick JS launched a troll campaign where a package called Everything, it depended on every other NPM package. So if you NPM install Everything, then it literally tried to download the repository.
That's kind of amazing. Wow.
I know it's devious, but it's also kind of like, okay, that's something else.
Yeah, and Python, the dependency trees tend to be much like shorter, I guess, and like smaller. Like you tend to have way fewer dependencies. They are sometimes like heavier, I guess, because like in Python, it's very common to have lots of native code. And like, I don't know, like PyTorch, like the PyTorch wheels that you download when they're zipped are like between 100 and 200 megabytes.
Wow.
Okay. Like, like all the ML stuff and all the native stuff, like those are like big, but the number of dependencies tends to be a lot smaller.
Yeah. I totally
It's also very common to ship like foundational packages with like no dependencies or very few dependencies, which is very hard to do in JavaScript.
Yeah, it is. It definitely is. All right, I think we're getting short on time here. I think I probably should let you go back and knock out another release of UV.
I do have to do a release today. Okay, thank you.
Awesome. Well, cool. So Tony out of the audience says, been using UV in production for a couple of weeks now. Awesome. Seems very excited about it. And also, I have too. It's an absolute delight. It hasn't.
Oh, thank you.
I know there were certain. Yeah, I know there's certain things that it didn't do like right away, but then it came out and you added them quickly. I know there was some criticism for y'all for developing this in private and then releasing it, and I just want to say, like, thanks for doing that. And what's the alternative? You start with just a blank GitHub repo and people start to say, well, you should do this. You should be doing that. Like, we have a vision. Let us just like get it a little structure in place and then we'll open source it. Like, give us a month, So I don't know. I think it's excellent work you're doing.
I appreciate it.
Yeah.
Yeah. Like I said at the start, it was different. It's different this time because anything we release, like,
you could work on a rough for a month and nobody cares until it starts to catch some traction, right? But this is the instant that it hits.
We knew people would at least look at it and at least try it. And I think, we wanted to make sure that whatever we released, first of all, was good, and second of all, that we were ready to maintain it. And I think with packaging too, it's like there's just it's just such a complex space that like I wanted to make sure that we had a lot of clarity in the messaging around what the tool is and what it's not, and like what we want it to be and what it isn't yet. And so I'm really happy with how the launch went, and I've really appreciated just all the excitement, activity, engagement that we've had on the repo. It's been like, I don't know. I mean, honestly, it's been a lot of work, but
Yeah,
it's like
sure.
really, really, no, but it's awesome. It's like so energizing for me and for the team.
And to see all the
And
people picking it up and making it the foundation of their projects, and yeah, it's really cool.
yeah, and it's cool. You know, I guess another like one other thing that's a little different this time is like I just talk to more people who work on Python tooling at companies now than I did when I released Rough, just because over the course of the past year, I've just met a lot of people and we've just talked about how they're using Rough and how they're not. And so just hearing some of those stories too of how like companies are starting to use it and like what the blockers are and like how much of a speed up it's providing has been pretty cool to see too. So yeah,
it's
no,
incredible.
I appreciate it though.
Yeah, you're welcome. All right, we'll leave with this final thought from Juan. I installed 94 libraries in around 2 seconds. Incredible.
That's great.
All right.
Yeah.
All right. Well, I'm excited to see where things go, and we'll maybe do a follow up when you've got some more of the ideas in place.
Sounds great. No, it's always a pleasure. Thanks so much for having me on. I really appreciate it.
Yeah. Thanks, Charlie. See you later. Thanks everyone for listening.